you're lost. You're thirsty. There's pristine white snow everywhere, glittering in the sun like nature's sports drink. You scoop some up and shove it in your mouth. Congratulations, you just accelerated your death. I know what you're thinking. Water is water, right? Ice, snow, liquid, same thing. Wrong, dead wrong. And I mean literally dead, because that innocent handful of powder you just ate is about to rob your body of more energy than it gives back. Drop your core temperature and roll out the welcome mat for hypothermia. While everyone assumes nature provides clean hydration for free, you're burning through calories faster than a marathon runner. All to melt frozen water in the furnace of your stomach. Smart move. Here's what we're covering today. Why eating snow is metabolic suicide. How to identify deadly versus safe lake ice by color alone. Why smooth icicles are safer than rippled ones, and what that ripple pattern actually means. Glacier ice that contains viral strains unknown to modern science. Sea ice that will dehydrate you faster than drinking nothing. The exact boiling times needed at different altitudes, because water doesn't boil at 212 degrees when you're on a mountain. And the 5-step protocol that actually works. When infrastructure fails and temperatures drop below freezing. Here's the physics that most people never learn until it's too late. Your body is a 70 kilowatt biological furnace, running at 98.6 degrees Fahrenheit. That's not negotiable. Drop below 95 and you're in hypothermia territory. Now you take that snow, let's say 32 degrees, and force your body to heat it up 66 degrees. But wait, there's more. Before your body can even start warming that water, it has to melt the ice first. That process, the latent heat of fusion, costs you 334 kilojoules per kilogram. In human terms, that's 117 food calories to melt 1 liter of snow. And here's the kicker, you need 8 to 10 liters of snow to produce that 1 liter of water, because snow is 90% air. Then you burn another 37 calories just warming that cold water up. Total cost, 154 calories for 1 liter of hydration. You just spent the energy equivalent of jogging a mile to get a standard 32-ounce water bottle. Meanwhile, if you had found liquid water at 32 degrees, you'd only spend those 37 calories warming it. That's more than 4 times more efficient. The math isn't just against you. It's actively trying to kill you. Every calorie you waste melting snow is a calorie you're not using. To keep your core temperature stable, to think clearly, to keep moving, to survive. And here's the sick joke. Hypothermia develops in under an hour. Dehydration takes a week to kill you. You're solving the slow problem by creating the fast problem. Strategic genius. But let's say you ignore the physics because you're stubborn or desperate. Or you read some blog posts from a guy who survived 1 winter camping trip. Fine, eat the snow. Here's what happens next. That freezing mass hits your stomach and your body immediately diverts blood flow to your core. Your extremities, your fingers, your toes, they get cut off from the blood supply. Vasoconstriction kicks in. Your body is making a calculated sacrifice, letting your fingers turn into frozen hot dogs to protect your vital organs. Within minutes, you lose dexterity. You can't work a zipper. You can't start a fire. You can't tie a knot. You're looking at your lighter, the thing that could save your life. And your hands are frozen claws that can't operate it. Irony doesn't keep you warm. And we haven't even talked about what's in that snow. You see white, you think pure. Nature doesn't work that way. That fluffy powder is 90% air, 10% water. You need 8 to 10 liters of snow to make 1 liter of water. That's not a snack, that's a full-time job. And while you're shoveling frozen air into your face, you're also shoveling in everything that snow collected on its way down. Air pollution, dust, pollen, bird droppings if you're unlucky. Industrial exhaust if you're near a city. And a delightful cocktail of bacteria that have been having a party on whatever surface that snow landed on. Let me tell you about the types of frozen water you're going to encounter when the grid goes dark and you're scrambling for hydration. Because not all ice is created equal. And the difference between knowing your frozen water sources and guessing is the difference between drinking safely and introducing ancient pathogens into your digestive system that haven't seen daylight since the last ice age. Lake ice, river ice. Looks solid, looks safe, looks like you just found an infinite water source. Let's talk color first. Black ice or blue ice, that's your friend. That's clear, dense ice that formed slowly in calm water at consistently low temperatures. It's strong. 4 inches of that will hold a human. 10 inches will hold a truck. That's the ice you want to harvest. But white ice, milky ice, that's compressed snow and slush that froze in turbulent conditions. It's 50% as strong as black ice. Same thickness, half the structural integrity. It'll crack under you when you least expect it. And if you fall through into that water underneath, you've got about 10 seconds before cold shock response kicks in. Your breathing goes haywire, and you've got maybe 15 minutes before you lose consciousness. Hypothermia doesn't wait for you to swim to shore. But let's say you make it. You chop out some black ice, you're feeling accomplished. Now you need to melt it and boil it. Always boil it. I don't care how remote that lake is. I don't care if it's on top of a mountain nobody's visited in 50 years. Giardia doesn't take vacations. Cryptosporidium doesn't care about your location. E. coli is thriving under that ice in the liquid water layer that never freezes because water is densest at 4 degrees Celsius. That's why fish survive the winter. That's also why pathogens survive the winter. Boil it for 1 minute at sea level. 3 minutes if you're in the mountains. No shortcuts. Icicles. Now we're getting into dangerous territory, and I'm not talking about the pointy ends. Smooth icicle, perfectly clear, no ripples, no bumps. That's relatively clean water. Rippled icicle, wavy ridges running down the length. That's contaminated water. The impurities create uneven freezing. It's a visual lie detector test, and most icicles fail. City icicles hanging off roofs and gutters, those are toxic waste popsicles. Bird feces, roof grime, atmospheric pollutants, road salt spray, exhaust particulates. All of it concentrated into a convenient frozen package. You want to drink that? Be my guest. I'll visit you in the hospital, assuming hospitals are still operating. Wilderness icicles are slightly better, but still require boiling. 3 minutes, minimum. The only safe icicle is a boiled icicle. Now let's talk about glacier ice, because this is where it gets truly horrifying. You're thinking glaciers are ancient, pristine, untouched by human pollution. You're half right, they're ancient. That's the problem. Glaciers are time capsules. They've been grinding up rocks for millennia, concentrating heavy metals. Lead, arsenic, mercury, all the greatest hits of geological toxicity. That milky color you see in glacier meltwater, that's glacial flour. Pulverized rock so fine it stays suspended. Drink that and you're adding a layer of sediment to your intestines that your body was never designed to process. But wait, it gets worse. Scientists pulled ice core samples from glaciers and found 33 viral groups. 28 of them were previously unknown to science. These viruses have been frozen for hundreds of thousands of years. And when that ice melts, they wake up. You're not just drinking water, you're drinking a virological lottery, where every sip could introduce something your immune system has never encountered. Standard water filters can't catch viruses. They're 0.02 to 0.4 microns. Most filters stop at 0.2 microns. Viruses laugh at your Sawyer filter. You need fine filtration and 3 minutes of hard boiling. Non-negotiable. Sea ice. This one's tricky because there's a right answer and a wrong answer. And the wrong answer will kill you faster than almost anything else on this list. First-year sea ice, fresh frozen salt water, still has brine pockets trapped inside. It tastes salty because it is salty. Drinking it will dehydrate you faster than drinking nothing. Your kidneys will work overtime trying to flush the excess salt, burning through your existing water reserves. You'll end up more dehydrated than when you started. It's a cruel joke. Water everywhere and not a drop to drink. Except this time it's ice everywhere, and it'll kill you if you try. Multi-year sea ice that survived several seasons, that's different. The salt gets pushed out over time through a process called brine rejection. By the second or third year, that ice is nearly fresh. Polar expeditions have used it for drinking water for centuries. It works. But you need to know what you're looking at. New ice versus old ice. Salty versus fresh. Get it wrong and you're accelerating your demise with every sip. So far, we've seen how eating snow burns more calories than it provides, how lake ice color determines whether you're standing on solid ground or about to take an involuntary polar plunge, and why glacier water contains viral time capsules from the Pleistocene era. Now let's talk about the frozen water source that makes glaciers look safe by comparison. And then I'll give you the actual survival protocol that works when temperatures drop and infrastructure fails. Permafrost. Now I know what you're thinking. I live in Ohio. Why do I care about permanently frozen ground in the Arctic? Fair question. Here's the thing. You probably don't need to worry about permafrost unless your post-apocalypse survival plan involves fleeing to Alaska. Which honestly sounds like choosing to play the game on hard mode when you could have just stayed home and died comfortably. But for the sake of completeness, and because I respect your dedication to comprehensive knowledge, even when it's geographically irrelevant, let's talk about why permafrost water is essentially a frozen cocktail of everything that can kill you. Served on the rocks, literally. Ancient frozen ground in the Arctic. You'd think it's just frozen dirt and water. You'd be wrong. There are 4,500 industrial sites in the Arctic that deliberately buried hazardous waste in the permafrost decades ago. Radioactive materials, chemical weapons, industrial toxins, all of it sealed in frozen ground that was supposed to stay frozen forever. Surprise, it's thawing. Those toxins are leaching into the water. And just like glaciers, permafrost contains ancient microorganisms. Staph aureus strains from thousands of years ago. Borrelia recurrentis, the bacteria that causes relapsing fever. They've been dormant and now they're waking up. Standard filtration won't save you. Boiling might not even be enough. Permafrost meltwater is a hard pass unless you have laboratory-grade purification. But again, unless you're reading this from Barrow, Alaska, you can probably skip this particular nightmare. And focus on the frozen water sources, actually within driving distance of your suburban fortress. Now let's talk about what actually works when you need water in freezing conditions, and you don't want to die doing it. Fire changes everything. You need fire. Not for warmth, not for comfort, for water. Fire is your water purification system when the treatment plants go dark. Find liquid water if you can, even if it's cold enough to hurt your teeth. 37 calories to warm it versus 154 to melt and warm snow. It's not even close. Drink it slowly, small sips, let your mouth warm it slightly before swallowing. If you chug ice water, you risk cold shock to your throat. A reflex spasm that can make you panic, hyperventilate, lose control. People have drowned in cold water not because they couldn't swim, but because their breathing went haywire in the first 10 seconds. No liquid water, then you melt snow, but you do it over fire, not in your stomach. Get a metal container, any metal container. Canteen, pot, even a tin can you scavenged. Put a small amount of water in first if you have any, just enough to cover the bottom. This prevents the metal from scorching and gives the snow something to melt into. No water at all? Start with a tiny amount of snow, heat it gently until you get a base layer of liquid. Then add more snow gradually. If you pack it full of snow and blast it with heat, you'll scorch the bottom before the top layer even starts melting. Slow and steady. Once you have liquid water, keep adding snow to it. You're building volume. Get it to a rolling boil. 1 minute at sea level, 3 minutes if you're above 6,000 feet. The temperature drops as altitude increases. At the summit of Everest, water boils at 158 degrees. That's not hot enough to kill everything quickly. You need time to compensate for lower temperatures. Boiling kills Giardia in seconds at 212 degrees. It kills Cryptosporidium. It kills bacteria. It kills most viruses. It does not remove chemical contaminants. It does not remove heavy metals. If you're dealing with glacier melt, urban icicles, or any source near industrial areas, here's the protocol. Melt your snow or ice over fire. Let it cool enough to handle. Run it through whatever filter you have. Activated charcoal is best for chemicals. Even a cloth filter helps with sediment. Then boil it again for 3 minutes. Yes, twice. First melt gets you liquid, filter removes the chemistry and particles. Second boil kills anything biological that survived. In a true survival scenario with no filter, you're making a calculated risk. Boil it hard, drink it, and hope the biological threats are worse than the chemical ones. Because at least boiling handles the biology. Here's the hierarchy. Liquid cold water is best. Boiled liquid water is better. Melted and boiled snow is acceptable. Eating snow directly is desperation. Sucking on small amounts of snow in your mouth to let it melt with saliva is better than swallowing chunks. But it's still inefficient and you're still cooling your core. If you have no fire, no way to melt snow, and you're genuinely facing dehydration versus hypothermia, then tiny amounts of snow melted in your mouth, swallowed slowly, is the least bad option. But understand you're making a trade. You're borrowing from your core temperature budget to pay your hydration debt. That budget runs out faster than you think. Let me be clear about the timeline, because this is where people miscalculate and die. Dehydration is a slow killer. You can survive 3 days without water, maybe longer if you're not exerting yourself. Hypothermia is a fast killer. In wet conditions with wind, you can go from normal to dead in under an hour. You can be moderately hypothermic in 30 minutes. Your brain stops working correctly. You make bad decisions. You take off your clothes because you feel hot even though you're freezing. It's called paradoxical undressing, and it happens right before you die. You need to prioritize your core temperature over hydration in cold environments. Period. If eating snow drops your temp, you don't eat snow. You find another way, or you accept short-term dehydration until you can build fire. If you want to keep your family safe when the system fails, subscribe. We analyze what others ignore. The tactics that sound good versus the physics that actually work. The Instagram survival advice versus the biology that keeps you breathing. This isn't entertainment. It's education for scenarios most people refuse to consider. Until they're already in them. This isn't a game. This isn't a camping trip gone slightly wrong. When infrastructure collapses, when the power grid fails, when water treatment stops. Frozen water becomes one of your primary resources. But it's also a minefield. Every decision you make about water in freezing conditions is a trade-off between hydration, energy expenditure, core temperature, and contamination risk. The people who survive are the ones who understand these trade-offs, who know which frozen water sources are safe, who can build fire to melt and purify, who don't panic and start eating handfuls of snow because they saw it in a movie once. Bottom line, test your water knowledge now. Practice melting snow over fire now. Learn to identify safe ice now. Understand the energy costs now. Map out water sources in your area. Know which ones will freeze. Know which ones will stay liquid. Know which ones will be contaminated. Teach your family these principles. When it's 20 below zero and the pipes burst and the stores are empty, these 5 steps could save your life. Fire for melting. Boiling for safety. Liquid over solid. Energy math over instinct. Knowledge over panic. This is real survival information for real scenarios that most people refuse to think about until it's too late. I focus on the physics, the biology, the uncomfortable truths. that don't fit into 3-minute feel-good videos. One last thing. Always consult with local emergency services and government agencies for specific protocols in your region. Regulations and recommendations vary. And most importantly, take care of yourself and your loved ones. The world's unpredictable, but preparation isn't.